I want to start by just giving you a little bit of background on me. I went to school at Berkeley in engineering. I graduated in the early 80s. And some of you might remember, or others have read about it in history books, that there was a big energy crisis at the time. And we were thinking a lot about energy back then. And one of the things that I did while I was in college, I spent the summer working on the solar hotline for the state of California. And at the time, we had a rebate program and a whole series of things to encourage people to use solar energy on their roof and think about solar energy. So one day, I got a call. And it was a call from somebody asking about solar clothes dryers. And they said to me, what do you know about solar clothes dryers? I'm really interested in solar clothes dryers. And so as a young engineer, I started thinking about things like this, big panels on the roof and ducts and complicated systems. And I said to the caller, can I put you on hold for a minute? And then I asked my colleagues in the room, so what about the solar clothes dryer? What do you guys know? And they all started laughing at me, saying, Peter, that's a joke call, okay? And so I got back on the phone and I said, are you talking about a clothesline perhaps? And yeah, so I learned that early on, sometimes the simple solution is innovative in and of itself. And when we start talking and thinking about innovation, it's not always the more complex and expensive and high-tech system that's the right answer. So I also like to think about things like carbon footprint. I do go through annually my carbon footprint and calculate it. Hopefully each year it's coming down a little bit. But one of the things I realized early on in this whole exercise of carbon footprinting is that my carbon footprint of the buildings that I design dwarfs my personal carbon footprint. And so I take the work that I do with a huge amount of responsibility, and I know that everybody here does as well. As designers, builders, operators, developers of buildings, we have to constantly keep in mind that the biggest and most important thing that we can do for the planet is on every project think of how we can make it better. And it's from that perspective that I have started, that I long ago started to dissect what's going on in buildings and how can we improve it. And my perspective has typically been not how can we incrementally improve it in small ways. I'm looking for dramatic ways to improve it because we all know that we need to come up with buildings that don't use 3% less energy than they use today. We need to come up with buildings that use half the energy of what they use today. And we're not going to get there with small incremental improvements. We really need innovation. And luckily, people are very excited about building innovation right now, and there's a lot going on. So let's start by looking at where we are and what's not working in buildings. It helps inform us on where we need to go. One thing I like to look at is lighting in buildings. And if you look at a lot of offices today, we have new lighting technologies and fixtures and ways of lighting spaces, and we've had those for 20, 30 years longer. But we still see offices like this that are dark, cave-like. In fact, there's lots of buildings where the building requires tenants follow the same type of lighting with parabolic troughs so that the whole building looks uniform. And so there's still so much that can be done to improve lighting, and there's lots of spaces that look very dismal. When we start looking at building controls and heating and cooling systems in buildings, the brain that controls building control systems is fundamentally not working in buildings. And those of you who work in building commissioning know exactly what I'm talking about. You can have a system that works close enough, but at the heart of that system, there's always going to be parts of it that are out of control. This is a graph, the same type of graph I see on almost every building of something that's fluctuating wildly. And this isn't over several days. This is a 5-minute oscillation, and this one happens to be the hot water temperature. And we're trying to maintain smooth temperature inside an office or inside of a building, and we can never get there when the hot water being supplied to the air handler or to the radiant floor is fluctuating wildly. So I see this kind of thing everywhere. In fact, one of my favorite stories about building controls is, and again, it's something that's happened to me over and over, is that I'll be on the roof of a building or in the mechanical room, and I'll be on my cell phone looking at a valve saying, you know, that valve is closed, and I call up the controls guy, and the controls guy will pull up on their computer and say, no, the valve's open on the computer. I said, no, I'm looking at it, it's closed. And so there's this disconnect, and controls tend to not work very well. When we look at surveys of office workers, and the Center for the Built Environment at UC Berkeley has now surveyed 50,000 people who work in buildings, and the results are saying 42% of those people are uncomfortable thermally in their space. And this is in essence, a dismal report card. It's something that we're asked as engineers of heating and cooling systems to design for 20% uncomfortable. In Europe, it's 10%, but the reality of where we are in the US today is 40%. So buildings are not delivering the comfort that they're meant to. On top of that, there's a race right now to design and build new buildings with lots and lots of glass. Floor-to-ceiling glass is something that I see more and more of. So we already have buildings that are not that comfortable. Add on top of that floor-to-ceiling glass and the glare that comes from that and the thermal discomfort from the sun shining in a window at your desk. Architects and engineers know very little about glare. In fact, most architects don't even know what the definition of glare from daylight is. And if you don't understand the definition and how glare works, how are you going to be able to design a building that deals with glare? We want daylight. We want views. I don't want to work or live in a building that doesn't have windows. I want windows. But we need to understand glare so we can create buildings that are visually comfortable and thermally comfortable and perform well. We need to really get into it. Luckily, the new LEED rating system has a couple things that refer to glare in a very simplistic way. But in order to make great buildings where people are feeling that they love working in that building, we need to really think about glare and understand it and design to better conditions. So if you look at where we are today, this is an image of two different buildings in New York City. One is the iconic Empire State Building, and the other is the Bank of America Tower that was built a few years ago, has a LEED Platinum rating, and it does have the floor-to-ceiling glass. Interesting few pieces of information about these two buildings. Now, New York City requires energy benchmarking of buildings. And that's something that is spreading around the US, San Francisco and eventually California, Chicago, wide variety of cities and states are starting to require that we benchmark our existing buildings and we report that data. In UK, they not only have to record or benchmark their buildings, but they also get a report card or a letter grade, and you have to post that at the front door of the building. So a lot of the new buildings who have a bad grade are they're desperate to retrofit their buildings and make them better. These two buildings, from the energy benchmarking data that's public, one uses half the energy of the other one. And the one that uses half the energy is the Empire State Building. And the Bank of America building was built with a lot of things to make it efficient. It's got daylight and daylight responsive lighting. It's got efficient HVAC, the whole bit. And I was at a conference and talked to a property manager in New York City, and I told him, you know, what's your thinking about this? Why would a new building with all this great equipment in the building be using twice as much energy as an older building? And he said, well, it's no surprise to me. All the folks who manage buildings in New York know that the floor-to-ceiling glass buildings, the new glass buildings, they use twice as much energy as the older buildings. So we can do a lot to make the equipment in buildings efficient, but fundamentally, and this isn't a surprise to me and many of us in the green building community, it's also the design of the building itself that is paramount in making a building efficient. So as an engineer, when I work on projects, the innovative thing that I bring to the table oftentimes is not about the latest gadget, but it's about, we need to talk about the envelope in an integrated way. And oftentimes, owners, developers, architects, they'll go, well, you're the heating and cooling guy. We'll call you back when we're ready. And I say, no, you can't do that. One way of looking at it is the size of the mechanical system in a building, the size of a heating and cooling system in a building is a measure of how poor the design is. The larger the system, the worse the building is. We need to be designing buildings where the goal is a very small mechanical system because the building itself is fundamentally efficient. Oftentimes, when I'm doing a design, I'll say, well, just turn off all the heating and cooling in the energy model and let's see how the building performs. And let's try to get the temperature in the building comfortable by a better building envelope, better design instead of a bigger mechanical system. So what happens with this knowledge of a lot of things in buildings aren't working? So how do we figure out and how do we come up with buildings that are more comfortable, that are people-centered, and what kind of innovations are needed to get us to where we want to be? I wanted to start with a interesting story, case study. About 6-7 years ago, I was contacted by a company in India. Infosys is their name. They're the second largest software company in India. They have 150,000 employees and 35 million square feet of office space. They build a new building, large building, 250,000 square feet every month, every other month. And they called me and said, we have heard that there's this thing about making buildings use a lot less energy and being sustainable and being more comfortable for the occupants. And so I got over there, and it was interesting. For such a large company, they introduced me right away to the CEO of the company, and we sat down and he said, Peter, I want you to help us design the best building in India right now. And I wanted to also to be in the direction of, if not right away, one of the best buildings in the world. So we sat down and I felt ready to go. I was really excited about the challenge. And we started designing a very different building from what they had been designing. We started thinking about how sun interacts with the building. We came up with a sun shading system that was very simple. What we said was two things. We want 90% or more of the building to be daylit during the day, that is daylight autonomy, 90% daylight autonomy, and we don't want any direct sun to come into the building. So it's simple, no direct sun, but 100% daylight. The direct sun is what causes glare, discomfort, and high air conditioning loads. So we came up with, this is the first building that we did, a shading system that did that with a light shelf and shading that blocked the direct sun, but allowed the space to be 100% daylit and without the glare. So this is a photo of the space. They don't have internal blinds because they don't need them. People work near the windows or in the center of the space. They have an even amount of daylight, and the building is very successful from the daylight perspective, but also the thermal comfort perspective and the air perspective. It's very clean air. We use this whole idea of a dedicated outside air system. We do not recirculate air in the building. We bring fresh air in and we exhaust it out. And then we provide the heating and cooling in this building with radiant cooling. And with the radiant system, which they had never done before and had never been done in India, the first building was 250,000 square feet, and the building was actually had two halves, and so we were able to figure out and actually measure that the radiant side of the building was using 40% less energy for cooling. So we got a building that had no recirculated air, no glare, 90+% daylight, 40% less energy use, and the radiant side cost 9% less to build than the more conventional variable air volume system. So consequently, the folks from Infosys have changed their philosophy about designing buildings to this more efficient and people-centered building, and they're now designing buildings that use 70 or 80% less energy than the buildings they were building before we got started on this endeavor. And they now have saved 40% of the energy overall that they were using before we got started. Infosys is now the beacon or the leader and the forerunner of sustainability in buildings in India, and everybody looks to Infosys for leadership. And I do want to remind everybody that this was done without incentive, without a utility incentive program, without a government mandate. It made good financial sense for the company. We've been working with a wide variety of folks looking at better buildings, and there was a discussion earlier about the red list, and one of my clients is Google, and Google has very aggressively worked on eliminating bad chemicals from within the building, and the discussion earlier was that that's a good beginning, but we need to take it further, and that is we need to look at preventing things like mold and using good filtration in buildings and all the best practices so that the operation, not just the day one of the building, is going to result in great air quality so that people feel healthy in buildings. That I think we're going to see a lot of, and in fact Google has helped to transform the market for a lot of building products, because when Google says, if you do it for us, we'll buy a lot of it. So carpet manufacturers, furniture manufacturers, all the interior building product companies are taking note and starting to develop products for Google and then ultimately for the rest of us. One of the things that we're thinking about a lot is this glare thing. And one of the strategies that we see in Europe and a little bit in the US is this idea of external operable shading devices. If you have a big west-facing facade and there's windows on the west, it's hard to, with a fixed shading device, control the amount of glare in the afternoon. So there's good examples of buildings with external operable shading devices, not only in Europe and other places, but even here in San Diego. UC San Diego recently built a building over in their medical campus that has the operable shading devices. And even in countries like Spain, where they don't spend as much money on buildings as they do in Germany, you'll see the external operable shading devices. We've got to start thinking about that to control glare in the afternoon if it's on the west side, but be able to open up and get the daylight earlier in the day. So also different seasons when you're in a hot climate that has hot and cold, these can make a lot of sense. One of the things that we're starting to design into buildings are electrochromic windows. And I was actually at the factory for this company called View Glass recently. And not only are they growing very rapidly and recently got a very large investment from a venture capital firm, but the price of the glass is coming down, and the performance is very, very good. So I think that we're going to see people wanting to use this as the price starts to drop. And the right way to look at these things is, how does it affect the overall cost of the building? So can we, in an integrated fashion, use a better glass that's more expensive than a typical glass, but downsize the mechanical system to help pay for the extra cost of the glass? That's the way to look at it. And a lot of projects that where I've been successful, we've taken the approach of the innovation is not only on the technology, but it's also on finding creative ways to make the building efficient and cost effective. People want efficient buildings, there's no doubt about it. The problem is oftentimes they can't pay more for it. We need to be creative on finding ways to make efficiency affordable, and that's where, when we think about the building envelope, we think about some of these initial things, they're much cheaper than adding more gear that's more expensive. One of the strategies that simple innovation that I spent a lot of time thinking about, my mentor, a guy by the name of Liang Lok, taught me, is that friction's a big deal. He taught me this almost 20 years ago. Recently, Lawrence Berkeley Labs came out with a report that said that the friction in heating and cooling systems accounts for almost half the energy. And the friction in heating and cooling systems is from fans and pumps. The reason why we need a pump is because there's friction in pipes, and we have to push the water to overcome the friction. And so engineers don't think about friction, but we start thinking about it in a more holistic way. We'll end up with piping that looks like the piping on the bottom image here, where the pipes move smoothly through the space with 45-degree angles and not 90-degree angles or T's. We're using Y's instead of the T's. We end up with pumps that are vastly smaller, sometimes half the size of what they'd be normally, just by looking at friction in the system. If you couple that with lower loads, if we have a lower load, we need less chilled water or less air. So we have lower loads, less chilled water, lower pressure drops. A lot of the systems that I design will have motors connected to pumps and fans that are 1/4 the size of what they'd be normally. And a lot of contractors look at that and they say it will never work. And I say, just go ahead. I've done the calculation, and we turn it on and it works. And this is the kind of thing that we're going to see people think about more and more as we start to squeeze out the affordable efficiency in buildings. There is a lot of technology coming down the road on making buildings more efficient. In Silicon Valley, the venture capital firms are really interested in pushing software solutions to make buildings better. One of the companies that they funded, it got funded by Google Ventures and some others. One of the VCs that helped fund Tesla is this company called Building Robotics, and their product's called Comfy. And the Comfy product gives users the ability through a web page or a connection on a smartphone to say, I'm too hot, I'm too cold. Please turn the heating down. Give me some more cooling. Right now, we as occupants of buildings don't have any ability to provide feedback into the system of what we want. It's more about what a thermostat wants, or in this room, what a thermostat that's right next to a big cabinet of hot equipment wants. Right? And when you look at the wall in many buildings, including this one, there's all these different things on the wall. Some are thermostats, and some are CO2 sensors or humidity sensors, or all these different things, and we just don't know how to interact. We have to call somebody, and that somebody, these days, they don't work in the building, they work somewhere else, and they might come out a week later after we've gone. So we need ways to allow people to be the sensors, for us to be able to be more engaged with our space so that we can come up with spaces that are more comfortable. Same thing applies to lighting. I've seen a variety of solutions. These are on the drawing boards. They're being tested in labs right now where people are able to directly interact with the lighting over their space, not just their task lamp. I've seen some tests in laboratories where ceiling fans actually follow users through a space. Your smartphone, you can elect to use it as a sensor locating you so that your preferences will follow you through a building. Another interesting concept is heating and cooling people, not the room. If you look at it, we really are focused on heating the room and heating the walls and heating all the equipment or cooling, and we're not focusing on the person. What if we have a chair that provides heating and cooling? So this is a product that's been developed up at UC Berkeley at the Center for the Built Environment. And a variety of things like this are going to come out where we're going to get more and more focused on delivering services like comfort, fresh air, lighting directly to the person, not just to the room. There's a lot of discussion on really what's going on in buildings. We've been measuring CO2 for a while, but CO2 is only one thing that's going on in buildings. There's a researcher up at University of Oregon by the name of Jessica Green who's studying the microbiomes in buildings. What she's doing is she's taking samples of the microorganisms in buildings and putting them through DNA sequencers. And what she's finding in buildings is that instead of a diversity of microorganisms that are in nature, that are natural, that are part of our environment, in buildings, they're more like a monoculture of microorganisms and on the like. And so you'll get office spaces that have more of a monoculture, and then the bathrooms have another monoculture of a different microorganism. And we're gonna start to understand buildings in a much deeper way and respond to not just CO2, but a wide variety of things. So I think there's lots of frontiers in buildings that we haven't even begun to explore. What I would do is encourage you to do two things. One, just go out there and look. And two, remember that we're never going to be done innovating on buildings. There's always going to be a lot of new things. Right now, I think is the golden age of buildings as far as innovation for performance. I think that there's not been a time where we've seen as much rapid innovation in buildings as we have right now. So it's, I think, a very exciting time. We're wrapping all these concepts together into buildings like LEED Platinum buildings, the Living Challenge buildings, regenerative buildings, net zero buildings. So when we're thinking about these aggressive target buildings, we need to think about all the different components that are going to go into making it happen. And I liked the discussion earlier about Oceanside, that start with a goal, but then we'll figure out the details. So there's a lot of details to figure out, but start with that goal. And that's been one of the things for me in projects. One of them that I worked with Matthew is this project at Missouri Department of Natural Resources, a state office building in Missouri. And the criteria was, we want a very green building, platinum preferably, but by the way, there's not a penny extra money available for this project. And we started from day one with that in mind. As a design team, we figured it out. And that building was first LEED Platinum state office building, and they didn't spend an extra dime to get there. So the stretch goal is the important thing. The details are how we're going to get there. These innovations are going to help. It's not that every building needs to be assembling every single innovation. We need to pick and choose the ones that are going to be affordable and appropriate for that project. And we'll be able to apply those in a wide variety of net zero buildings and aggressively sustainable buildings. I do take a lot of interest in what's going on with the climate change rallies and such, and I heard about the one at San Diego where there was a thought of a couple hundred and 1,000 showed up. This one in New York that happened on Sunday, the same day as the one in San Diego, 300,000 or more people showed up to that climate rally. And these are a lot of young kids, college kids, and there's a whole divestment movement. And when I was in college, it was about divesting from companies that do work in South Africa. And now the push is, let's have colleges, universities, pension funds divest from companies that are deeply involved with creating negative impacts on the climate. This is, to a certain degree, I've been on board and thinking about that on my own for a long time, but it's caught me by surprise how quickly this is all taken up. And what I've talked to a lot of the young college kids. I teach at Stanford, and I guest lecture at a lot of other places, and the college kids are looking for something that's much more aggressive than what we're even talking about. In California, we're talking about this 30% renewable energy. College kids are saying, we want 100% renewable energy. We want to talk about and envision a future where it's 100% renewable. And we're going to hear a lot of people, I think, in the future say 100% renewable. Lancaster, California has a small town with good solar resources. That town has said, our whole town is going to be renewable, solar. Greensburg, that was talked about earlier today, that is a town in the Midwest that said, we're going to have every single new building in our town that was wiped out, we're going to have every building be a LEED Platinum building. And this is not a tree-hugging town. This is, by and large, a much more conservative town than what we would find in California. And they got it. This is an issue that crosses many different perspectives. And I think we're going to see people wanting us as design professionals to go further, faster. We are going to need to think about architectural aesthetics. We want green buildings to be beautiful. They've got to be beautiful because we want people to want them. but we've also got to think about performance aesthetics. And those of us who get this, we need to go to developers and architects and say, you know what? That 100% glass building is not a green building. 100% glass buildings are not green buildings. There's no way we can make that building work. It won't be comfortable thermally and visually, and it won't be low energy. We can make the equipment super efficient, and we're doing that. But at the end of the day, we're going to need a lot more. Remember what I said, that the size of your heating and cooling system is a measure of how good you're doing. In an all-glass building, we need a lot of heating and cooling. So we need to think about the architectural aesthetics, but also performance aesthetics. There is a beauty in a performing building, and the occupants will get that once they move in. So really what I like to think about is this idea we can't solve a problem with the same thinking that created it. We are the group that's going to create the new thinking. We need to communicate in a friendly and excited way to all of our peers in the building and construction and ownership development community and say, this is what people want, it's what people need, and it's really the future of buildings, and it's our duty to go there. So thank you very much. So I do have we do have a few minutes for questions if people want to, 5-10 minutes. So, if you have any questions, please raise your hand, or comments, suggestions. Yeah.
Okay. For the example that you showed, I think it was in Missouri that you mentioned, where it was a Z and Eagle, and you did it with no extra cost.
It was LEED Platinum.
LEED Platinum.
Yeah.
Okay. LEED Platinum with no extra cost. Were there any stories that you might share about the process the owner went through on the way? Things that they might not have realized, they had to trade off this instead of that, or they were kind of uncomfortable, but they realized in order to meet their goal, they needed to come along with them.
Yeah. So what I've seen, and that's so many of the projects that I worked on have exactly the same situation where they want to be aggressive, but they just don't have a lot of money or additional money. So much of it requires education on the part of the owner, because they're going to need to learn new ways of doing things. The building that we're going to be designing isn't going to look like the building that they built 5 years ago. Same thing with Emphasis in India. When we started going there with them, saying we're going to design a much better building, 70 or 80% lower energy than what you've been designing just 2 years ago, it created a lot of institutional resistance. And luckily, in that case, in the case of Missouri, and in all the other successful buildings, green buildings that I've worked on, there's a core group of people who have the enthusiasm to say, you know what, we're going to spend the extra time to figure out what you're talking about, look at the risks and rewards, do some research, maybe visit some other buildings, and get into it. If somebody says, I don't have time to even think about it, it's problematic, because the building that we're designing that's going to be much better is going to look different than the building that they're used to. So it really does take, in these early days, some additional focus. Now, having said that, what's happened now in many markets in the US, contractors are telling me that a LEED Gold building doesn't cost any more than a standard building. And in fact, because building materials have gotten better, system efficiencies have gotten better for lighting and HVAC, they can design buildings that don't look that much different. And so they don't require that much additional oversight or thought or education. So I see in Silicon Valley all the time owners just sort of saying, fine, do the LEED Gold. I won't think about it. You guys just do it. And it will look similar to what they're used to. So that's the success. That's this. We had the early adopters. I remember LEED Silver and Gold was really hard, really expensive. And then as we got the experience and the momentum, the economies of scale and a variety of other things, it starts to become mainstream. So that's what we're doing. With the net zero energy buildings today, they're tough. They're really tough. I was the designer for the Venter Institute up the road, a first net zero lab building. And that was very difficult. But the whole idea is by the time we get to 2030 in California, it's going to be required to design net zero energy commercial buildings, that by then it will be a whole lot easier than it is today. And hopefully, from an affordability standpoint, very easy. Yeah. So in the back, yeah.
Thank you. Great presentation. I'm just curious if you could speak a bit to cradle-to-cradle design in regards to looking at net energy savings, and sustainable development.
From the perspective of materials, or?
Yeah, materials.
Yeah.
That's it, yeah.
Yeah. Okay. So a couple interesting things. When the first time I worked on a project, we started looking at the carbon footprint of the materials, and we also looked at the carbon footprint of the building. Interestingly enough, we found that the energy consumption in the building was 10 to 20 times larger than the carbon footprint of the materials. So this is like 15 years ago, and we said, okay, we'll focus on the big hit, and that is the energy use in the building. Fast forward to where we are today, if we're designing net zero energy buildings, now we can, in essence, plus or minus, say that the carbon footprint from an energy perspective is zero. Now, 100% of the carbon footprint of the building is materials. So I think there's a growing awareness that the material and the footprint of the material is a big deal. So we talked about deconstructibility or cradle to cradle. There is a group of folks thinking about what's going to happen to this building 50 years from now. Is it a building that will be able to take apart and easily reclaim or recycle the building materials? And I'd like to say that there is a group working on that. It's still in its infancy, and it's still something that we need to talk about. I think they're much further along in that in Western Europe. In Germany, they have rules about cars and the recyclability of cars. There's actually requirements for the recyclability of all the materials in cars. We don't have that in the US. We don't think that, we're not that advanced. So I do think it's something we need to talk about, and I do think there's a lot of great solutions out there. Right now we have, as you know, our solution is grind up the building the same way we grind up cars and sort of separate out what we can, the steel rebar and the concrete. And in Oakland, I'm from Oakland, there is a car grinding facility. They literally grind cars up into little chunks that are about a 1/4 inch, and they send it through an automated machine that separates the metal from what they call fluff, and then all the metal gets shipped to China for recycling. So that's how we do it, right? Not the most enlightened way, because the fluff is 50% of the car, and that just goes in the landfill. Is really problematic. So we need to think about buildings in a more advanced way from that perspective. Yeah, sure.
You touched on it, I'm not sure if you're the subject matter expert, but Google's Healthy Product Declaration, and then other major corporations that are joining in on that, and then maybe even the labs and testing agencies that are joining in on that. It's kind of a very interesting collaboration that's not being talked about much yet.
It's interesting, as Google doesn't like advertising what they do. I can't talk about them because some of the stuff that I showed and has been presented by me with their approval as part of their public forum. They're super quiet about most everything they do, but certain things they let out, right? But by and large, what's going on the material side, I think that's where they're the most vocal in the green building community. And a lot of the people that are on the green team at Google go to the materials conferences and talk about what they're doing. I'm not the expert on that, but they've gotten the bug, and that's because the leadership at Google is really into creating great environments for their workers. They really want their workers to be healthy and happy, because if they're not, they'll go work at Facebook, right? So they get it. And so this is where the non-energy benefits of making great buildings can oftentimes far outweigh anything like energy. And if we think about the Empire State Building, which I had the opportunity to help out in that retrofit, the owner, and this is the problem with developers in general, they're never going to pay the energy bill for the building. So why would the owner push to have a low energy building? So at the Empire State Building, it was clear to the ownership there that if they make a better building, a low energy building, and do some other things to improve the air quality and the lighting, and it actually has pretty good daylighting naturally, and they advertise that, get the word out, occupants, potential tenants will understand that that's now a green building. It's a good building, and they'll increase their occupancy rate in the building, which they did. They did very, very well. After the renovation of that building, and it was primarily an energy renovation, the occupancy rates went up substantially in a very measurable way, and that's dollars and cents. So developers are getting, I saw a panel of building management companies in New York City, and they said that law firms in New York City are saying that if it's not a green, has at least some green credentials in the building, it's on the checklist for tenants. It's not the primary thing, but they're like, well, we want a guard in the lobby, we want a certain amount of parking, we want a renovated elevator, we want this address. Oh yeah, we want the green building. And if you don't have it, you're not getting the check on the list. And there's so many great office spaces in New York that just go on to another one. So the owners in New York are all on board and really aggressive about trying to do the LEED E-bomb or new construction, making better, greener buildings, because the law firms, the tenants are saying, the young kids coming out of school are saying, oh, aren't you in a green building? I really, as a young person who's heard all about, doing the right thing for the environment in green buildings, I want the company I work for to be in a green building. Even a law firm is saying that, or even law firms are saying that. So I think it really gets down to this dollars and cents thing, and it's so much more than just energy. Yeah, so in the very back of the room, yeah.
So I'll give you a multi-part question. You can take it wherever you want. So the IGCC, they're moving toward an outcome-based code, right? And so what do you think that means for existing buildings, and what would be the impact on just moving the needle for the majority of the existing buildings?
I think the interesting thing is that, and this is what's happening in the UK, once people start becoming aware of how their building compares to a building next door, or a building that's similar, has similar occupancy and similar systems, and they see that their building's using a lot more energy, not only would they be embarrassed into doing something, but they'll also know that it's possible. I think a lot of building owners right now have the feeling that we're doing the best we can possibly do. And there's not a lot more. We put in that variable speed drive, and we did a retrofit of the filters or something like that, and all this other stuff that we're hearing about. We can't sort through it, and so we're good. But I think what's going to happen is there's going to be sharing of information, and people are going to realize that it's possible to do much better than they're doing. There are going to be some regulations that come out, and I personally am not waiting for them, because I think we can do a lot, and there's a lot happening right now without them. But in California, there is a proposal or assembly bill to, in the future, create an existing building energy requirement. So there could well be some requirements come out that force the worst performers to do something. But I think at the end of the day, tenants are also getting sophisticated about energy use. They're the ones who are paying the energy bills. It's going to be another thing on their checklist of, well, what's the energy cost of this building? And if it's 30 or 50% more than another building, they're going to take note of that. So, yeah. There was another question. No? Okay. Yeah.
You brought up mold and dedicated outdoor air filtration. I'm wondering what you think is healthier, a filtered air system or a natural ventilation approach which doesn't get filtration?
Yeah. So a typical engineering answer, it depends, right? So we work with a lot of tech clients in Silicon Valley who happen, unfortunately, to be right near a freeway. And if you measure the air quality outside of the building during commute hours, it's actually not very healthy. And if you had operable windows at that time of day and open the windows, it'd actually be a lot worse than having filtered air. So they get that. And so a lot of companies are saying, we want great filtration first and foremost. And the standard for most commercial office buildings is not having operable windows. But I also work for a lot of clients who are not right next to a freeway, or who are not in Beijing or other cities that, or LA 30 or 40 years ago. They say, we really could benefit, or they understand we could benefit from the operable windows. Everybody intuitively knows that occupants are going to want operable windows. All of us have operable windows at home. Why wouldn't we want it in the place where we work? And what happens so often is mechanical engineers stand in the way of operable windows, because we work very hard to produce hot and cold air and create a temperature in a room. And when somebody opens a window, oh no, we're going to lose control. And engineers are control freaks, right? From our perspective, occupants are irrational. So we get a little freaked out. And really what and I'm very active in the engineering community, giving talks and doing workshops and committees and things like that. What I say to our community is we need to figure this thing out. We need to get comfortable with it, because before there was air conditioning in offices, there was operable windows, and the buildings work great. So there's concerns about humidity and all these things. We can deal with it, and there are great examples now of buildings where we have operable windows, and if they're open at the wrong time, there's a little interaction with the HVAC and it turns it down or off. But I've worked on a lot of buildings with natural ventilation operable windows, where manually operated, that people get signals through their computer that it's a good day to open or close the window, and people respond to that and do it. They just need a little bit of prompting, and by and large, people will do the right thing. So I feel very comfortable with the idea of operable windows. When I go to Europe, or I go to places like South Korea, Seoul, that I'd say I don't know the exact number, but it seems to me like half the high-rises in Seoul have operable windows. Half of them. Places like Germany and even Barcelona, Madrid, all these places, high-rises have operable windows. It's the kind of thing that we never see in the US, and engineers get very nervous about. And I think we need to find ways, because at the end of the day, occupants love it. And guess what? It's a much lower energy way to go, and it produces better comfort. And by and large, in most cases, the air is better outside than it is inside. So that's my feeling about it. Not all engineers agree with me. So that's that thing of balance. Engineers, we need to come there. Architects need to come to us, and we need to go to architects, and we all need to be thinking about the occupants. Yeah.
I just had a quick question about an existing building versus a ground-up building. You talked about a lot of technology and simple solutions that work. Can you still meet the same energy targets, same performance targets in an existing building?
So I would like to remind you of the case with the Empire State Building, which is using half the energy of the new Bank of America Tower. Okay, so yes, existing buildings done right can have very good energy performance. And a lot of the older buildings that we have, not 1980s, but earlier, when air conditioning wasn't very good and electric lighting wasn't very good, there was an art to designing buildings that didn't need a lot of that, because we didn't have a lot available. In California, we actually have a long history, or a particular moment in history in California where we designed fantastic schools. And those of you who work in schools will know about the finger building design. And all up and down California, schools were designed with finger buildings, parallel to one another, aligned with the east-west axis, so that you could get a small band of south-facing glass with an overhang, so no direct sun, and then larger amount of north-facing glass, so the classrooms were fully daylit, and many of these classrooms where there was heating were provided with radiant heat, which is also a low-energy way of heating, and that was all done in the 1960s. And then there was a philosophical change. It was about education, not necessarily energy, but the late 60s and the 70s of, kids will perform better if we just get rid of all the windows. And that actually proved to be wrong. But there was about a 10-year period, and if, again, those of you who work in schools, you go see these 1970s era schools, and there's not a single window in the classroom. It's a disaster. So this is what I like to remind the folks in my office who were don't even know what the Vietnam War is and stuff like that, that, hey, you know, not all great things were invented in the last 10 years. There's some good stuff that we can learn from, and today we have better ways of figuring things out and optimizing and refining. We should take advantage of what we've got today, but also learn from what was done before. Thank you very much. Yep.